Okay, now in this video we are going to discuss the standard error of estimate, and in the previous tutorial of ours we were discussing an example related to the agricultural survey stuff related to the fertilizers and the production of your corns. So on that basis we just draw the scattered plot, and then we draw the best fit regression line, and that's how it comes out to be. Now all the points related which are lying on the best fit, we are going to analyze what is exactly the difference between the actual values and that of the estimated values, which are also said to be the predicted values, and that is said to be the error. Now how we are going to calculate the standard error is that these crosses that we have just drawn here, they are basically the points which are so present in the sample data right over here. Right over here. And these points, this data actually x is corresponding that of your y. So these values are said to be the actual values or the observed values while performing an experiment or while doing the survey. On this basis, we just draw the scattered plot, and then we draw the best fit line. So in order to make a table of your estimated values and actual values, so that we can come to know what is exactly the difference between these two values, and in other words you can say that what is the actual distance between those two values, so that we can predict what is the standard error of the estimate. So for that purpose we have to draw a table in order to make a proper calculation. So here I have just done that, so you can see. So this is the values of x, and this is the corresponding value of y regarding the previous problem. And over here you can see that these are the actual values so recorded during the survey or while just compiling the data and all that. So these y dash, these are those values which we are going to estimate on the basis of this line of best fit that we have drawn. Okay, so you can see that on x2 the corresponding value of y is your 4, so your y dash is 4. Okay, let me use a different pen. And once the value of x is 1, the corresponding value of y is your 3. Okay, so this is your 3. This is the for 3, the value that is given to you in the data, or what you call the actual value of y with respect to 3 value of x, so it is 3. Okay, and once if we just try to move on, then the predicted value is on the line of best fit with respect to this 0.3 is lying at 0.5 over here on the y-axis. Okay, this is the predicted value and this is the actual value of y. So you see, this is and it should lie on 5, so it is 5. Okay, so for value 3 the actual value is 4, and the predicted value that should lie on the best line of best fit, or what you say the regression line, it should be 5. Okay, now talk about for this 0.2 which is mapping on which is having the actual value 3, where this 0.2 is getting mapped on the best line of fit. So you see this 0.2 which is representing 3 point, it should give it should be mapped at 0.4. so this is the predicted value of y with respect to 0.2, and this is the actual value of your y with respect to the data value. Okay, so this is your 4. Okay, talk about your 4 point representing the actual value 6. Let's see where this 4 is getting mapped, and this 4 is getting mapped on 6. That's right, so actual value here and the predicted value both are overlapped, both are same here. This is 6. So here you can see the difference or the distance between these 2 points is 0. So now talk about your 0.5. So 0.5 is having the actual value 5, whereas it should map, if we just try to trace it where it is going to lie over here, then we have to find out where it is getting mapped on your y-axis. So let us draw this thing in order to get the correct idea. So I've just drawn this thing. You see at 0.5 the corresponding value of your y with respect to the regression line is mapping at 0.7 on the y-axis. So the predicted value is your 7. So over here we have to write it is 7. So this is the predicted value and this is the actual value. Similarly, 3 is getting with respect to the table, it is representing the actual value 5 here, and what it is giving us on the best fit, 3 is getting mapped on 5. So this time also the predicted and actual values are same. So here, this is it. So you see actually the error is the distance between the predicted value and the actual value. Okay, so now let us find out the difference between the predicted value and the actual value. This is the actual value, this is the predicted value. Just put the complement in order to make a difference. So it is 4 minus 4, 0. Okay, this is also 0, and I'm just writing it directly. It's 4 minus 5 give you minus 1. It's also minus 1. Okay, this is 0, and this is your minus 2, and this is also 0. Alright, so now you have to take out the square, because once it is a requirement of the formula of your standard error of estimate. So 0 is square 0, 0 is square 0, minus 1 is square, give you a positive 1. And so do here. Same thing here, minus 2 square give you 4, and this is it. Now you have to find out the summation of these things. Okay, we have to find out the summation of the difference of the values of the square of the differences. So it comes out to be 6. Alright, so this is it. Now let us calculate the standard error of estimate. And standard error of estimate is with respect to the sample data is represented by this notation, and is sorry okay, so now it is 6 upon, and here the value of n is 7 because these are the 7 ratings. So the strength of the data is 7 upon 2. So it is therefore, now the basic math is here, and we just do that. So it is under root 1.2, and I'm taking the square root. It gives you the final answer 1.095. So this is the standard error of your estimate, representing just the difference or the distance between your estimated value and that of the final value and the predicted value. So I hope you have understood the concept of your standard error of estimate on the basis of the best fit line and the actual values given in the sample data.